To begin the test, you're in the Test Setup tab. You want to first select the impulse type, lateral, lark, which is left anterior, right posterior, or route, which is right anterior, left posterior. When you choose lateral, notice that the lateral head trace is in bold. If you choose lark, the blue head trace for lark is in bold, and if you choose route, the pink head trace for the route is in bold. This is because you're determining which plane of the gyroscopes you're recording from. So lateral will be a horizontal plane, lark would be running from left anterior to right posterior, and route would be running a plane from right anterior to left posterior. The other thing I want to point out is, let's go back to lateral and look at the training curves. When I choose lateral, and then when I choose lark and route, they're changing. So you have to make sure you choose the correct test for what you're getting ready to perform on the patient. Let's go back to lateral. For patients with spontaneous nystagmus, select the checkbox, spontaneous nystagmus. It prevents good impulses from being rejected inappropriately. Pupil detection is performed to ensure the system tracks the pupil properly prior to calibration. Position the pupil in the ROI region of interest. Over here in the test setup, you see the green square. You want to make sure the pupil is positioned within the green square. You can do this either by left-clicking and dragging the green square, or clicking on the pupil to center the pupil inside the green box. So let's click on the pupil, and now the green box is centered. And as you can see over on the left-hand side, the white is the pupil and the black is the background. Once you have the pupil centered in the green ROI box, you want to click OK. Now you see the real-time trace. The orange is the head and the green is the eye.
You can look at the pupil in one of two ways, either grayscale image or pupil location. Grayscale image shows you the eye. The pupil is white with the green crosshair. Pupil location makes the background black with a white pupil with a green crosshair. When you first put on the goggles, typically the pupil thresholding is quite good, but if you have more noise from mascara like I have today, all you have to do is click auto threshold, and it'll set your pupil thresholding for you. Make sure the patient's eyes wide open and they're not blinking when you click auto threshold. If you want to record the video, you need to make sure the checkbox is selected under record, and the default is to record. If you want to be able to play back your traces, your eye video, as well as your head position feedback and your synchronized room video together, you need to make sure you record the eye so that you can play that back.
Now the patient will stare at the fixation dot. Observe the green eye trace in the real-time trace window, ensuring that it is as flat as possible when the patient is fixating on the fixation dot. Turn the lasers on. There are two laser dots projected on the wall. Ask the patient to look at the left dot, then the right dot. This ensures the camera is tracking the pupil. If the crosshair fails to track the pupil, jumps around, or does not stay centered on the pupil, move the threshold slider to make further adjustments. Adjust the pupil detection by clicking plus or minus, or by sliding the bar.
The pupil detection for V-HIT and VOR are very similar, and I'll show you the difference with all the other tests. So for V-HIT and VOR, you have a region of interest box that's 100 by 100 pixels. And here's the VOR. And that's because we're collecting the data at 250 frames per second. When we go to the other test, we'll go to gaze here, you have a box that is 160 by 120. Otherwise, all the pupil detection is exactly the same. The screen does look a little different for all tests. Outside of V-HIT, you have a gray real-time trace window that shows you the eye in green and the head in orange. But the pupil detection procedure is exactly the same for all tests.